we learned how to find derivatives in what we call explicit form. Explicit form is when it is solved for y, when y is by itself, and we have y in terms of x. So we go ahead and find the derivative using quotient rule, product rule, whatever, chain rule. Implicit function is when it's not solved for y. So implicit, we have x's and y's. And could we solve for y and then find the derivative? Yes, but sometimes, like if you look at the one on the board, would you want to solve that equation for y? No. So we're gonna find the derivative first and then solve for the derivative instead of solving for y. So the steps, you are going to take the derivative of both sides. Then because y is a function, just like when we took that derivative rule quiz. So anytime you take the derivative of y, you have to chain on a dy over dx. And remember, dy over dx is the same thing as what? Y prime. Okay, so it's the derivative of y. After you do that, you're going to solve for dy over dx. When taking the second derivative, we are going to have to plug in dy over dx where needed. That's going to make more sense when we do a problem, but basically you found the first derivative, and when you go to find the second derivative, you're going to take that answer and plug it in when you need to. All right, so I don't think this stuff is very difficult. The last problem we do is pretty long, but these aren't bad. All right, so x, what is the derivative of x? 1. So what's the derivative of x squared? 2x. Plus the derivative of y squared, you first find the derivative. So the derivative of y squared would be 2y, but since y is a function, we have to chain on the derivative of y, which is dy over dx. Equals, and the derivative of 25 is just 0. And now all we're going to do is solve for dy over dx. So I'm going to subtract 2x over and divide by 2y. So dy over dx is negative x over y. And that's it. Okay, so instead of writing, like, we can't really write f prime of x anymore because our derivatives have x's and y's in it. So that's why we're using this dy over dx or y prime. Yes.
And where do you do step 4? Like when you
This one we're doing second derivative. So when we get to, I think that's one of the later examples, we'll do second derivative and you'll see. All right, so this next one, do you want to distribute first? Is that how you would approach this problem, or do you want to do product rule? Distribute, okay. So if I distribute, I'm going to get x to the 4th plus x squared y squared equals y squared. And now when I find the derivative, you do still have to be careful because this is going to be product rule. Okay, because x squared is a function and y squared is a function. So you're going to have to do product rule. So finding the derivative of x to the 4th is 4x cubed. And now I'm going to do product rule. So I keep the first function. Derivative of y squared is 2y times dy over dx. Plus, now the derivative of x squared is 2x times y squared equals the derivative of y squared is 2y times dy over dx. So again, take a minute, make sure you know where all those came from.
Change the dy over dx to y squared.
Okay, because this one is not finding the derivative. So this is just bringing that down. The only time you chain on is when you're taking the derivative of that function. Good question. Okay, so now it's a little bit harder, but we need to solve for dy over dx. So that means anything that has a dy over dx attached to it, so like this term and that term, they need to be on the same side of the equal sign. And then without dy over dx need to be on the other side. Are you okay with me doing that well, it's only one step. So I'm going to take this term and minus it to the other side. Okay, so I'm here. 4x cubed plus 2xy squared. And then on the other side, I have 2y minus, I'm going to bring that 2 in front. 2x squared. Oops, forgot my dy over dx. And now we can factor out a dy over dx.
We can get 2x squared.
Um,
2y dy over x minus 2x.
so this part here,
So at the bottom, like.
Well, when you, you
Here?
dy over dx minus 2x squared y dy. And the right,
To the right.
oh my gosh, here,
the
here,
next one, yeah, above it.
here.
The negative two
right,
x.
right.
Next term.
Yeah, that.
Where'd I get that? I just reordered this. I put the 2 in front. Right? Okay. All right. Is that what you're asking? Okay. So now I'm gonna divide by this to solve for dy over dx. So. Divide by 2y minus. I'm gonna put it over here because I'm running out of room. So dy over dx is equal to 4x cubed plus 2xy squared over,
Y minus 2.
did I recopy it right? All right, so this is where we ask when do we stop? Well, I can see that I can divide everything by a 2. So I would probably reduce everything by a 2. I could also factor out an x on top and a y on the bottom. But if nothing cancels, then you don't need to factor it out. All right, but I'm going to go ahead and reduce this by 2. So 2x cubed plus xy squared all over. Remember, everything has to divide by 2 in order to reduce it. Okay, yes.
Can you just put y prime instead?
Okay, so this is the same thing as y prime. Yes. So when we chain on dy over dx, if you put y prime, that's not wrong. The reason why I'm writing it this way is to get you used to it. In this chapter, we do word problems. And the word problems involve time. And so we're gonna be taking the derivative with respect to time, which means everything is going to have chain rule. And so I'm getting used to this notation for the future. But can you write y prime? Yes, it's not wrong. But when we get to the word problems, you won't be able to.
Why is everything gonna have chain?
Why does everything have to be chain rule?
It's gonna have chain.
Because we're gonna change, instead of finding the derivative with respect to x, we're gonna be finding the derivative with respect to time, with respect to t. Because calculus is really what the study of what happens over time. And so how to use it in real life, like we want to know how is something changing over time? And so rate of change is derivatives. So you're going to be finding the rate of things changing over time. So we have to first learn. All right, next one. We all remember the derivative of sine? Cosine of y. But then remember, derivative of cosine u was, sorry, the derivative of sine u was cosine u times u prime. So here, this one I'll do y prime for you. So we're gonna chain on a y prime. That's the same thing as dy over dx. Equals, what's the derivative of x? 1. And now we're solving for y prime. I used y prime instead of dy over dx. Just so y prime, which is, so I'm dividing by cosine of y. So I can write it like that. I can also write it as dy over dx. And what could I change 1 over cosine y to secant y? So either one of those are fine.
So maybe a y, you chain of this dy.
Yes. Anytime you have a, so think of y just like you did with u, it's a function. Because if you solve for y, it's gonna be y equals, and then you have a bunch of x's. So y is a function.
Did we, like, when we made it cosine, did we technically take the derivative of slice?
No, we took the derivative of sine, kept the angle the same, and chained on the derivative of the angle.
Okay.
All right. Next one, when we have ln or log, before we find the derivatives, we make it way easier by expanding.
Already explained.
So I'm gonna rewrite this as ln x plus ln y plus 5x equals 30. I just expanded. And now I'm going to take the derivative. So derivative of ln u is u prime over u. So this would become 1 over x plus, I'll use y prime again. So this one would be y prime over y. Can I do something?
It's not.
Is it, oh, is that the same thing as 1 over y times y prime? 1 over y times y prime,
Yeah.
yes. Like y prime over y is the same thing as 1 over y times y prime. And it's also the same thing as dy over dx over y, which is also 1 over y times dy over dx. All of those are equivalent. Derivative of 5x is just 5, and the derivative of 30 is 0. And now we're solving for y prime. So I'm going to move everything that isn't have a y prime attached to the other side. Then I have to multiply by y, so this whole side gets multiplied by y. Y prime, which is also dy over dx, is equal to -5 minus 1 over x y. Can we distribute that y? Yes. Do you have to distribute the y?
No.
No. But it could be written like that as an answer. What else could they do? Make it a common denominator. So this would need an x, so they might write it as that. So any of those are correct.
They could also take out a negative.
They could take out a negative. Did I do something wrong? No, they could have taken out a negative y on top. But I don't factor anything out unless it cancels with something in the bottom. All right, question so far? Is the next one the second derivative? Okay, so this means second derivative. It's like y double prime. So in order to find a second derivative, we have to first find the first derivative. But didn't we already do that?
In the first one,
Yep. So from example 1, what was the derivative?
negative x over one.
Negative x over y. So we found the first derivative in example 1. So the second derivative is the derivative of the first derivative. So I'm going to find the derivative, which I write like this. That means second derivative. And then how am I going to find the derivative of negative x?
Quotient rule.
Quotient rule. So we are going to do quotient rule. So it's going to be low d high minus high d low. Derivative of y is dy over dx. All over low, low. Okay, so again, normally you would have to find the first derivative and then find the second derivative, but because we already did, we just took a step away. Yes.
When you find that derivative of y, don't you have to add on another to the whole dx? Or is that with this stuff?
This, remember, it's only when you're taking the derivative of y. So this is low d high. So the low, I did not take a derivative. That's why it's just a y here. But then when I do d low, that's the derivative of y. That's why I have a dy over dx. Is that what you're asking? Okay, yes.
Would that be our final answer?
No, because they're gonna say, find the second derivative in terms of x and y. This is not in terms of x and y, so this is that step 4. This has to be plugged in there. So you have to replace dy over dx with the expression of what dy over dx is. You don't need that.
I understand.
We don't need our computers, right? Yep. It is, but x was negative, so I changed it to a plus.
Wait, what, like, you said, we put dy over dx, that's the derivative of y, right?
Yep. Yeah.
Do you want to have a you just find the derivative of y?
Yep.
So 1 times r.
1 times the derivative of y. Yep.
It's because there's so small. There's y just like say it was like 2y, sorry, 1 time.
So when we find the derivative of y, the derivative of y is 1, but then times, you have to chain on the derivative of y, which is dy over dx.
So it's 2y would be 2 times.
Yes, if it was 2y, it would be 2 times dy over dx. Yep. So now I plugged in what the actual first derivative was into the expression, and now we have to simplify.
Oh. It's like slide.
I was finding it's low D high minus high, which was negative X. So I went ahead and made the minus a plus.
Whenever we second, then we always have to plug in
Yes.
the first one.
Yep.
And
You'll always have to plug in the first one into the second one. All right, so now we need to simplify this. So what's that? Negative Y minus X squared over Y, all over Y squared. We need to get rid of that little fraction. So is that, I think everybody multiplies by the denominator. So I'm gonna multiply the top and bottom by the denominator to get rid of that little fraction. We have to remember, we have to distribute. So what is my final thing? The negative Y times Y is negative Y squared. Minus, when I do X squared over Y times Y, those Y's cancel. To just give me X squared. And then over Y to the third. So could they factor out a negative? Yes. Do you have to factor out a negative? No. Yes.
Do we have to always leave it so that we don't have like a fraction?
Yes. You know, there's always, we practice it because multiple choice answers are gonna be simplified. And if you don't practice ever simplifying, you're not gonna be able to get the answer in a fast, because your exam is timed. All right, this next one, I want to see if you can do the very first step. I want you to find the derivative.
Yes, ma'am.
And maybe to make sure everybody don't forget that 4xy is a function times a function. After you've done the first step, look up and see if you got the right same thing I did. Yes,
No.
no? So again, this here, I kind of grouped those together. And I grouped Y together and I was doing product rule. So this is A here, this is B prime. This is A prime times B. So that's the product rule that usually students will forget. When you see XY, you have to do product rule. Is there anything else you? All right, now see if you can solve for dy over dx. That means get all the dy over dx's. So like this term has a dy over dx and this term has a dy over dx. They have to be on the same side of the equal sign, and anything without can go on the other side. Minus what?
minus
by a show of hands, how many of you moved the dy over dx to the left side? How many of you moved it to the right side? Okay, oh, we're about half. I'm gonna move it to the left. It's okay if you moved it to the right. We're gonna get the same answer, eventually. All right. Somebody who did it the other way, can you tell me what you got? Wait, hold on, dy over dx. You got 3x squared. Uh-huh.
4x minus 4y.
Okay, I want you to see, because whoever wrote the multiple choice question could have done it my way or could have done it the other way. And you need to see if you can see that those two answers are the same. So what can I do to get them to match? Well, if I factor a negative out of the top, and I factor a negative out of the bottom, those negatives will cancel. And then do you see that they match? Okay, so be aware that you don't know how the person moved the variables, but they are equivalent. Yes.
Plus one in the original equation.
Derivative of 1 is 0. So that turned into a 0. Yes. Yep.
So you know, when you did 3y squared dy over dx minus 4x, that, you can't make that like 3y squared minus 4x dy over dx. But they have the same.
Which one?
Here, 3y squared.
Oh, but 4x, like this and that are not like terms. So you can't combine them. All right, now the piece of information, we haven't found the answer to the question. We're finding the derivative at 2, 1. So because my derivative has x and y in it, we need both the full ordered pair. We can no longer write that I'm finding f prime of 2 because I'm using 2 and 1. So I'm going to show you just a little bit different notation. How I'm going to find the derivative, so dy over dx, and then I'm going to put this little bar, and I'm going to put the ordered pair. That is the notation we use for finding the derivative at a point. Okay, I have to use that because my derivatives have x's and y's. And now I'm just going to substitute in. So 4 times 1 minus 3, 2 squared over 3, 1 squared minus 4 times 2. And somebody tell me what that, what's that? 4 minus 12 over negative 8 over
36.
negative 5. So 8 over 5. We gotta like lock in for this last.
How does,
It's negative over a negative,
Oh.
which turns into a positive. All right, what else? So,
You move like rearrange the top, right?
Yep.
There. Doesn't the negative 3x squared come, isn't it negative?
for,
Like right there, you do 4y minus 3x squared on top of that, 4y minus 3x squared. Then you rearranged over there, 6. You made it 3x squared.
no, this was, this was if I would have moved the dy over dx to the right
I
side.
got there and I saw that and I was.
Yeah. No, this is right. This is right, and this is also right. Yeah. Okay, this last example is super long. It involves a lot of algebra. Okay? There are more than one way to find the derivative. Like I could find the derivative using quotient rule. But using quotient rule, I'm gonna have, within quotient rule, I'm gonna have product rule is gonna be pretty ugly, right? So sometimes we find derivatives using logarithmic differentiation. And what that, if the directions say find the derivative using logarithmic differentiation, you're gonna take the natural log of both sides. So the first step I'm gonna do is take the natural log of y and the natural log of all of that, x plus 1. And what do logs help us to do for two expressions?
Separate.
Separate. So I can expand that. And then remember, derivative of log is just u prime over u. So it will make the derivative a lot easier to find. So I'm going to put it underneath here. So ln y. And I'm going to expand the right side. So that's going to be ln x plus 1 plus ln x plus 2 minus ln x minus 1. Okay, division is subtraction, multiplication is addition. I went ahead and distributed the negative sign.
Like, I did Ellen.
Oh, but you can keep expanding.
Okay.
So like you could have done ln of the top minus ln of the bottom and then expand it further. All right, so now derivatives. Derivative of ln y is y prime over y. Derivative of ln x plus 1 is 1 over x plus 1. Plus derivative, that's just going to be 1 over x plus 2. 1 over x minus 1.
And because you're doing
U prime over u. Yep, u prime over u. And then what do we think we're gonna have to do? Common denominator. 4 different ones, but I'm gonna give you a hint. If it makes it a lot easier if you combine this and this because they're conjugates. And then if you combined this one and that one. Okay, so combine the two fractions in yellow, get a common denominator and combine them. Then combine the two fractions in blue, get a common denominator, combine them.
or ladder.
Yes, because you can switch around things.
They're adding more. Yeah, but it has the same whole thing.
Wait, even looks great, the big profit was less. Yeah. Yeah, so let's do that.
Maybe I should do different colors here.
What kind of find common denominators? How many common denominators?
Yes. Okay, so all I did right now is rearrange. I put the x plus one and x minus one next to each other, and the x plus two and x minus two. Now I'm gonna get, this needs an x minus one. Not multiplying. Doing what? Multiplying the conjugates. I'm going to, after I get the fractions to match, because I have to add them first. Like before I need to get the conjugate, or get the fractions together. You get a -2. What I'm doing is x minus x is 0. -1 minus 1 is -2. Now I'm gonna combine the other ones. So x minus x is 0, -2 minus 2 is -4. I went ahead and multiplied the bottom out. Now I'm gonna combine those two fractions. Okay. So I distributed -2 and I distributed a -4 and combined in like terms. Okay, but what do we have to solve for? Y prime. So I'm going to have to multiply both sides by y. But I want this in terms of x. I'm gonna. You'll see why I'm doing this in a minute. So instead of x squared minus 1, I wrote it back to x plus 1, x minus 1. Yep. Just because it's fun. So remember way back at the beginning of the problem? That's what y is equal to. So I'm going to put that in for the y. So instead of this y, I'm just going to put in. I know, I told you.
Where'd you get the Wi-Fi? It's in
Of course you do.
I think we're not gonna do like closer.
How'd you get that?
What do you mean?
Okay,
I'm still.
this y right there is here. But where did it first come from? Is over here. It was y prime over y, so I had to multiply both sides by y.
Oh.
So why would I do that? Other than it's fun. Some things are gonna cancel. So what can I cancel? So my derivative is negative 6x² plus 12 over x minus 1, I have 2 of those, and x minus 2, I have 2 of those. What?
Let me fix some of that.
It's not bad, it's just long.